I'm here to talk about circuits, and particularly one-wire automotive circuits. If we can understand what a one-wire or a frame-ground automotive circuit is, it becomes easier to understand why we need circuit protection, fuses and circuit breakers, and how shorts can happen in a car and the damage that they can cause. So before we go over a frame ground or one-wire circuit, we're going to look at a really simple series circuit. We have a simple circuit here, and I want you to look at the pieces of the circuit. We have a power source. This is our battery box, and we have our positive lead connected here and our negative lead connected here. We have wires or conductors to conduct electricity to our load, which is our bulb, and then more wires to conduct those electrons back to the positive side of the battery. So electricity is the flow of electrons. Electrons are negative in charge, and we know because we've heard this before that opposites attract and like charges repel. So electrons are coming out of this box, and we've provided a path for the electrons to flow. We see them flow in this light bulb right here, and this is a two-wire circuit. I have a path or a wire from ground and a wire to battery positive. It does not matter which wire you break. The minute that we open the connection in any place, there's no longer a place for electrons to flow, and so the light goes out. So now that we looked at a two-wire circuit, a simple one, let's take a look at a one-wire circuit and take a look at some of the problems that arise and how easy it is to short circuit something. Ready to look at one-wire frame ground circuits. And to simulate our frame, I've got a table. What this table and frames have in common is they're both made of steel. Both are excellent conductors, and so we use a vehicle's frame not only support our car, but we also use it for its properties of conducting electricity. So I've got my battery here, and this is as close as we're going to get to a car battery to simulate 12.6 volts. And what I'm going to do, just like a car, is I'm going to take the lead from my negative terminal, and I'm going to go ahead and attach it to my frame. Now, what's important here is not only is this alligator clip my negative terminal, but now this entire bench has become battery negative. And so if I touch battery positive to any part of this bench, and I do not put a load between battery positive and the bench, I've created a short circuit. A short circuit is a circuit that has a path from battery positive to battery negative with no load between them. In the circuit we just looked at, the light bulb was the resistance between positive and negative, and that resistance slows the flow of electrons down and limits current. A byproduct of current is heat. When you allow excessive current to flow, you will see heat. That means wires melting down, insulators catching on fire, things get hot. So in order to protect our car and our circuits from excessive current and heat, we use fuses. I've mounted a fuse in this battery positive alligator clip right here, and we're going to connect the light to it. So I have battery positive hooked to this light bulb. You can see only one wire is going to the bulb. And now when I touch the bulb to battery negative or the table, I should illuminate the bulb. And it works. So that's a one wire or a frame ground circuit. Now let's look at the potential problems that this causes. We're going to take a close look at a fuse, and that'll help us understand why these are so important. So if we're looking at this fuse right here, we can see that inside the fuse there's a loop of metal connected from one side to the other. So this fuse is designed to be a conductor. This side is linked to this side. But in the event of high current, and this fuse right here is rated for 60 amps. So if we exceed 60 amps, this loop is designed to burn open and protect the rest of our circuit from being melted down or catching on fire. So we're going to connect this to our battery box, we'll hook our light back up and take a look at a fuse working, and then we're going to simulate a short and see what happens to a fuse when there is a short. So you can see that our bulb is connected, and if we touch the metal bench, the light illuminates with just battery positive connected to it, because the bench has become our path back to ground. Well, the problem with this is that our alligator clip here, or even any part of this wire, if it were to rub through and touch the bench, we've created a short circuit, because the electrons don't need to go through the filament of the bulb anymore. They can go directly into the bench. And what we're going to do is we're going to touch this clip to the bench, simulating a short circuit. This could be a wire that ran along the body and had vibrated back and forth and rubbed the insulation off of the wire and now touches bare metal. That's what a short circuit is. So we're going to cause a short. We should see this fuse burn open. Don't blink or you won't see it. So I'll drop the bulb. As soon as I touch the bench, current is allowed to flow through the wire back to ground with no resistance at all. So here we go. 1, 2, 3. So what's happened is, as soon as I exceeded 60 amps, and 60 amps is a lot. If you take a look at this alligator clip, it's not moving because it got hot enough to weld itself to the bench. If we look closely at the fuse, you can see that right in the middle, it's burned open, just like it was designed to do. So now there's no longer a connection between this tab and this tab. The circuit is open. Once it's open, electrons cannot flow, and we don't have to worry about things getting any hotter. So you can see how fast a short happens, and most importantly, for technicians or technicians that are learning, is when you have a problem and you check your fuses, this is always a great first step, and you find a fuse and it's burned open, the cause is not the burned fuse. The effect is the burned fuse. The cause is a short. So once you've located the burned fuse, that's the start. Now you need to find the short.